you, Jon. Thanks for that kind introduction. Thank you for the invitation to be here today. It's good to see so many people in central London. It's good to be back in London. And thank you also, Jon, for coming up with a title for me, because I was invited to Keynote, and I think at some point I was asked for a title and an abstract, and I just didn't reply to that. So Jon just put this on the programme, so I thought I'd better talk about unleashing the fury, whatever that might be. So let's start by talking about the state of Scala. Scala has ahead of it in the next year, 2 years, 3 years, maybe longer, a period coming up of probably great change. There's a lot of things happening, all because we're getting our first significant major new release in probably over a decade, depending on how you judge significance. But Scala 2 was, I think, came out in 2006, so it's been maybe 13 or 14 years since we last had such a dramatic change happening to the language we're using. So I actually did a little poll at the company I'm working with in Poland, Ipfs Lab, and asked some of the people there what they thought were the biggest problems with Scala. So I work out what the top 10 Scala issues were with the language, with everything around it. Does anyone have any ideas what they might have suggested? SBT. That's a very specific one. Let's call it build tooling. IDEs, that was mentioned. What? Implicits, yes. Slow compilation. You're good. Drama. Let's have a look at what I collected. The Scala compiler is too slow. This was, I think, the most suggested issue, and has always been an issue, really, for as long as I can remember. In fact, probably longer than I can remember. Implicit's too complex. We don't understand how they work or why they work. The community is too divisive. This was mentioned. Drama. How ironic that I'm saying this here on this day. There are too many ways to do the same thing. How many people find this with Scala? Yeah. Kotlin stole all the newcomers. I don't know if that means that all of us are kind of old hands at Scala. There's no new young blood coming up. We're all sort of 3 or 4 years of experience behind us.
They're not worthy.
Scala is not a good fit for scripts or small programs. Maybe you didn't consider that. Maybe you just used Bash. I've heard some people have gone to Bash recently from Scala. Maybe we can bring them back. The build tooling is difficult to understand. IDs are not good enough, by some measure of good enough, but maybe that's relative to the other IDs for other languages that we're familiar with. And publishing libraries is too difficult. How many people here how many people are library authors who do not find publishing difficult? There's a couple. Oh, okay. All right, you're doing better than I ever did. I just gave up trying to publish something, and I'll just go and write a new library instead. And finally, I think this is number 10, people try to do Pascal in Scala. So this was my list. And this is going to be the subject of the talk today. Some of these I'm going to look at very briefly. Others I'm going to look at in some more detail. And I'll talk about what I'm doing to try to improve the situation. And hopefully, my goal is to make you see that actually, for the vast majority, maybe even all of these, we're going to see significant improvement over the next few years. So what's going to be different in the 2020s? We're the last month of this decade. It's exciting, isn't it? Scala 3 is going to be released in the 2020s. Maybe towards the end of next year, maybe early 2021. Fury will be released. Is that an asterisk there? We'll come to that later. Metals, which is which gives us the IDE experience that we're starting, at least I am starting to learn to love as a 20-year Vim user. Metals is giving us the IDE experience we're learning to love with VS Code and other IDEs. But in the 2020s, Kotlin will still be around. That's inevitable. We'll still be, if it is a competition, then Scala will still be competing with Kotlin. And Haskell will still be loved by its users and feared by people who don't use it. That will continue to be true. So let's look at the first item on my list. The compiler is slow. How many people are happy with the speed of the compiler? And how many of those people who are happy have more than 10,000 lines of code to compile each time?
Although each time is incremental.
Ah, okay, so incremental. Okay, so so one point worth making is that we have had many progressive developments over the years that have improved our compiled performance. Incremental compilation is one of them. Significant improvements to the performance of the Scala C compiler have made it much faster than it was 5, 8, 9 years ago. And they tend to happen sort of very gradually at the same time as the amount of code we've got increases. So we tend not to notice it so much. But the compiler has been getting faster and faster, and I think if you did a straight comparison, it would be 2 or 3 times faster for the same code than we would have seen a decade ago, maybe even 5 years ago. But the Scala 3 compiler will not be much faster. I think that's maybe the disappointing news from this talk. Scala 3 is doing much the same things that Scala 2 is doing. It might be a newly rewritten compiler, but it's going through the same processes, it's applying mostly the same algorithms, and we're not going to see a huge amount of difference in the raw compilation performance. But some of the slowest operations in our compiles will no longer be possible, so we can't slow it down by doing the things we used to do. What I'm talking about is macros. There will be new, more principled approaches to metaprogramming in Scala 3, and these will not have the same performance issues that were caused by macros. This is an improvement because we will be able to do the vast majority of things we did before. The only difference is we may have to write them in a different way. I think that most of the performance we're going to see coming from Scala over the next few years will be from build tooling, from the tooling around the compiler. Better parallelism in particular. More parallelism and doing less work are the two things that I think will help us most. Thanks to Bloop, which was developed at the Scala Center over the last couple of years, particularly with Jorge Vicente Cantero, the cost of going from source code to bytecode has come down dramatically. The overhead of initiating that compilation is much lower. And that is something that I have taken advantage of to the greatest extent I can with Fury. How many people here know about Hydra? Cool. How many people are using Hydra?
We try.
More people should try. More people should try. Hydra is developed by Triple Quote, by Julian Dragos and Mirko Dotta. They have, using their extensive knowledge of the internals of the compiler, they do some analysis of your code that allows it to parallelize and deduplicate compilations in ways that couldn't be done before. And it's faster. For most code, it allows you to reduce the complexity of the build. Certainly with a lot of the builds I design, I sort of try to modularize it as much as possible and get parallelism between those modules. With Hydra, I could just give Hydra all of the source files, and it would work that out for me. And I would get those benefits without having to try and work out where my module boundaries are. And Hydra works with Fury. It works with Fury because it works with Bloop. And I connect to Bloop, Bloop uses Hydra as its compiler, and I get these benefits automatically. So that's fantastic. If you're using Fury anyway, which is basically just me at the moment. But not for long, I hope. Another development which was introduced in Bloop is pipelining. How many people know about pipelining? Right, pipelining allows you to start start a dependent compilation before the dependency has even finished compiling. Now, let me show an example of an anonymous compilation. This is a build. It builds one module, then when it's finished building that, it generates some class files and it builds the next one. And then maybe there's two modules which depend on that, so it can build those in parallel. That's good. And then the final module at the end there depends on both of those, so it has to wait for them both to finish, and then that compiles. We've got a little bit of parallelism going on in the middle there, but not much else. Now that same build, and each of these bars is the same length in total, could be split, broadly speaking, into parsing, type checking, and bytecode generation. Now in the version at the top, we generate the bytecode, and then the next phase of the compiler goes and reads that bytecode that we've just generated to reinstantiate the objects that we generated the bytecode from. That is a waste of time. What pipelining allows us to do is to start type checking immediately when the previous type checking has finished. We've got a fully populated symbol table there, which is enough to start compiling this next dependency. Parsing doesn't have any dependencies, you just check that the syntax is well formed. That can happen early on. So essentially, the time it takes to get to the end of compilation is much sooner than it would be otherwise. So this is a feature of Bloop. It's currently experimental. From what I can tell, it doesn't seem to work with incremental compilation, but from a clean compile, that would be much faster using pipelining than it would be without. Cool? Yeah. There's another feature that is, I'm aware, is in development by a couple of parties at the moment, which is outline compilation. This has the biggest benefit that it allows us to see errors sooner. Now, compilations, we tend to keep doing them until we get a successful one and then we stop. So there's sort of a survivor bias there. The failed compilations, the one which generate errors, are actually the more common cases. So if we can get those errors sooner, if we can get to the error cases faster, then this is a benefit. What outline compilation does is it just compiles the signatures. It looks at the methods, doesn't care about the body of each method. It generates the signatures, generates enough bytecode for the next step to start, using pipelining again. And then when it's got to the end, which it'll get to much faster, I mean, there's no runnable code because it doesn't do anything. When it gets to the end, it can go and backfill all of the method bodies. And it may find further errors when it does that. But essentially, it's doing the same amount of work in a different order, which will help us get to the errors sooner. So one way to make compilation faster is to not do it. To not run a compilation when we don't need to. If we know what the outcome of the compilation is going to be, because it's already been done either locally or by someone elsewhere, that's one compilation we can save ourselves the trouble of doing. So we can cache, potentially. Fury builds, by default, will be deterministic. You will be able to do random stuff if you want to. That's sort of an opt-in. You can do network access in your Fury build code if you really want to, but you will be aware of what you're doing when you're doing that. You are playing with fire and Fury. that wasn't planned. Fury builds will typically be deterministic, and that's and any module, which is a collection of source files that will be converted into bytecode, can have its inputs hashed and its definition hashed, which gives us a number, a long number, which uniquely represents not only the inputs, but also, in theory, the outputs if it's deterministic, the output bytecode. So we can use that hash, and we can store a map. This is basically what a cache is. I'm describing a cache here. A map from the hash of the specification of the build to the binaries that get produced as a result of that. And if we have the file locally, then that's great. We can just access the file instead of doing the compilation. That will almost always be faster. And Fury does not need to build it in those cases. Now that's nice for you on your computer, but if you're working in a company, a small company or a large company, you've got several people who are probably compiling a lot of the same code. So why do all of them on your local network need to be compiling the same stuff? You've all got the same dependencies. Maybe even if there are 3 or 4 different branches, maybe even dozens and dozens of branches active in your team at the same time, someone will have compiled each of those branches. Someone will have a cache that contains a built binary corresponding to the specification for that build. So why are we building them all repeatedly on our own machines? That shouldn't be necessary. So we should be sharing them. We should be able to access compiled code across the network if we know if we know the specification for that, if we know a specification for what that binary should be. And IPFS, the Interplanetary File System, which is one of the most grandiose names for any technology I've ever heard, provides a dynamic, resilient peer-to-peer network, still sounds grandiose, for sharing data. And it is a fantastic and extremely clever idea. And it will allow us potentially to have compile once, but depend anywhere. You don't have to depend on things locally. Now let's talk a little bit about IPFS. Maybe people here used Napster in the 90s or similar. I'll be passing on names to the authorities. IPFS is a peer-to-peer network in the same way that Napster was, but with 25 years worth or 20 years worth of further technology development included within it. The core interface to IPFS is very simple. If you give it some data, like a file, it will give you a hash of the data. If you give it a hash, it will give you the data. It's a one-to-one mapping, or at least it looks like a one-to-one mapping. If you know anything about hashing, you'll know it's technically not a one-to-one mapping, but the hashes are large enough that no one can ever envisage in the entire history of the universe a conflict. And everything else in IPFS is sort of details around this. It allows us to convert from a hash to some data and from data to a hash. And it will share that data across its network, and you can join the network. Machines can come and go as they please, and it maintains membership, and everything kind of just works, regardless of where you are in the world or, in theory, in the universe. So, I said we could have access to data using IPFS from other people's machines, accessed by its hash, if we know what that hash is, to save us the trouble of compiling. But we can actually go one level further than that. If we have a brand new project to compile, we could proactively push that compilation out to the network and other machines that are nearby us and ask them to do the compilation at the same time. So on a LAN, at least, network latency is low. Doesn't cost a lot of time to send requests or data across your LAN. And if you look at your own machine when it's compiling, if it's compiling two projects in parallel, or two instances of the compiler at the same time, probably most of your cores, if you have a 4-core machine, probably all of them. If you have an 8-core machine, certainly the majority will be almost maxed out from anecdotal observations. Your machine is working as hard as it can. It's doing as much work as it can at any one time. So if you had some help from another machine, another set of cores, that was accessible at low latency, that would be fantastic. So we can potentially push those compile requests out to other machines nearby, or even to a compile server, which serves that role, and get better parallelism, faster compiles, and then of course when everything is compiled once, it never needs to be compiled again. I'm going to be focusing on that next year quite a lot. This is going to be a project which is quite exciting for me, the ability to make compilations faster using Fury. The process, just to quickly run through what that involves, given a module, which is a specification for the inputs to a compiler, Fury will hash all those inputs. So the hash uniquely defines that compile run. It will then check whether an IPFS hash exists corresponding to that module hash that we've just calculated. If it does, great, we'll use it. We've got the compile result. If it doesn't, we build it locally. And when we've built it, we give that compiled binary to IPFS, and we get a hash back from IPFS. So we give it the data, give it the binary, it gives us the hash. And then we will broadcast that hash somehow across our network for some definition of our network, maybe different for different users. And they will then become aware that the hash is available for that particular module, and they won't need to build it, they can just download it from IPFS. There. So compilations will get faster by a number of means. So most of you, I'm sure, came to Paul's talk this morning. I've already said a lot about this before, so I'm not going to say much else. Between us, we've covered most things. But I think we know that people will continue disagreeing on issues. It's happened in the past. It's happened in other communities, in other societies. It will continue to happen. As Paul said, people think what people think, and we shouldn't believe otherwise. I think people are also starting to realise that it is very draining for the rest of us to have to watch dramas or what are often described as dumpster fires evolve. And it's just generally unpleasant. But what I hope is that people are starting to see that, and they realise that the majority of people in the community don't want that, they don't like it, and people should work harder to avoid it. And on a very positive note, extremely positive note, if you've seen the Scala thank you campaign that Daniela Fregola set up over the last couple of weeks, this is absolutely worthy of applause. It's helped to highlight the often forgotten thanks to so many people in the community. And this, better than anything else, has drowned out those dramas. So I'm extremely grateful for her, and I think the thanks for her is extremely worthy. So enough about that. Another criticism with Scala: there are too many ways to do the same thing. Yes, there are. Different ways on different days. And when I've used one way of doing things, I want to try a new way as well. It's always exciting to try new things. This is more of an educational problem. I think that we have a lot of materials out there. They're often presented in a way that says, well, you have these choices. You can do it this way, or this way. And people are not people are often not given an opinion as to which is the best way. I think there is an opportunity there to be a little bit more opinionated with our documentation, with blogs, with education material. This is one of the more minor issues, but I hope that we can develop over the next few years, in particular for Scala 3, some opinions and some ideas and some recommended routes and libraries, frameworks and so on, maybe less so frameworks, but certainly libraries for solving certain kinds of common problems. There's no magic or silver bullet for this, but it will, I think, continue to evolve. People try to do Haskell in Scala. I think we have Tony Morris to blame for this, amongst the list many things that he gets blamed for. He introduced Scala Z back in around 2006 and taught a lot of people a lot of things about how to program Haskell, but using Scala as a vector for Haskell. And this had a lasting effect. People were a little bit, they felt sort of allergic to things like subtyping or variants, and they avoided them. This was not using Scala to its greatest potential. And these ideas, I think, are starting to be seen that Scala does have its own ways of doing things that work differently from Haskell. It has a very different type system. And I'm excited to see more people embracing variants, which is it's a very complicated topic. I spent the last 2 days teaching variants amongst other things, but my hope is that Scala will be used as Scala rather than as simply a poor man's Haskell with a load of features we don't use. And I'm appreciative of the things that Jon has said recently, that Scala is really its own thing and it has its own way of doing things. So if Jon's saying it, then there's probably some truth in it, at least, maybe more. So on to build tooling. It's difficult to understand. This has been a motivation for me to try and make things better. If you want a summary of problems with build tools, Lee Hao Yi wrote some criticisms of SBT. I could probably add to those some criticisms I have of Mill. And then there's things like Ant and Maven. We have so many obvious complaints about those, nobody really complains about them anymore. So the current situation is that I think things are still harder than I can imagine them. So my goal is to try and make them as easy as I can imagine them. I think that to start a new project with SBT, it still takes a few lines of code. There's still a bit of work to be done in getting started before you can write your first Hello World program. I think that's too much. I think we can do better. So let's do a little demo on getting started using my approach, which is the Fury way. So I have a console here. Can you see that?
Yeah.
It won't go any bigger, so don't ask. So, well, to get started, I want to run just one command to start with a fresh project. So I'm going to type Fury. Oh, I should probably install Fury to begin with. I think what I want to do, yeah, I think this is what I want to do. Fury, I had the command there. Curl Fury build, and then just pipe that into shell, and it will install. Oh, okay. Well, in the future, maybe it will. Maybe that will work. For now. Oh, it's already installed on my computer, so that's okay. We can do the demo. So I'm going to start by doing what's called cloning a layer. Now you'll notice I have tab completion here, because I can't remember the commands. and my network connection's gone down, I think. Oh no, we're okay. I'm going to clone a layer, and I'm going to press tab there, and it's going to offer me some layers, which it's getting from the internet somewhere. And I'm going to get started with Scala new. And I'm going to put that into a directory called new. How about that? Well, it looks like there's nothing there. You may be mistaken, though. I've got a project set up here. The project is called new. You can see that just there. It has a module called core. It's got a directory set up already. This is a pre-configured template for you to start work on. A template can be anything you like. It can be a complete project if you want. It can be anything that Fury can represent. So let's create some source files. So I'm just going to use my favorite IDE, which is Vi, and write a simple, basically hello world application. Does that look like it will compile? Yeah. Let's try and run it. So that runs that compiled and ran, and there is the output. Hello, Functional Scala. That was not much work to get our first Hello World program running, and it compiled quite fast. It'll get faster and faster the more times we do it, as the JVM that Bloop is using gets warmer and warmer. So that is the getting started demo. That's it. It's very brief. There was the criticism IDEs for Scala are not good enough. It's a little bit ironic that I'm having to talk through this slide because I haven't really used an IDE in 15 years. But there is a lot of work that started several years ago. JetBrains has done wonders on making IntelliJ for Scala a really fantastic user experience in the vast majority of cases. And I think probably the majority of you are IntelliJ users, and I imagine you're mostly happy. You may have noticed that there are certain issues with types that occur occasionally, where you get red squiggly lines when you shouldn't, when you don't expect them, because it's not using the real Scala compiler. It's using IntelliJ's quick version of re-implementation of the Scala type system. So it's not perfect in all cases. It's not perfectly correct. And starting a couple of years ago, there was a project called Metals, headed by Olaf Park-Pierson, who has created this project, and it allows us to use to have VS Code or other IDEs instruct Scala to compile stuff and to return errors and information about the code, and it's working better and better and better. So good that I'm actually considering stopping using Vi and adopting VS Code. I'm getting there slowly. And that's being developed with cooperation between the Scala Centre and more recently with Virtuous Lab in Krakow in Poland. And I'm also working with Virtuous Lab on Fury. They are helping me with development. They're keeping me pushing development forward. They're making sure that I make it work for systems that other than my own laptop, which is important, I think, important for adoption. And we're going to have closer and tight integration between Fury and Metals. It's going to be very natural to use Fury as your build tool and Metals, usually with VS Code, as your IDE. I've got a blank slide here, and I've completely forgotten what's meant to appear here, so let's have a look. I just forgot to include the title, that's all. So when you initialize Fury, it automatically creates the files necessary for Metals to construct a BSP connection to Fury. BSP is the build server protocol. It is a protocol, a lot like LSP for IDEs, to allow Metals to instruct Fury to start a build, and so that Fury can pass the message back to Metals to say, we're done. And this can be shown inside your IDE. So this is the start of the integration. And that was actually developed with a lot of help from JetBrains, from Justin Kieser, who committed this large chunk of code to Fury, and it makes Fury a BSP server that can be used with Metals or anything else that speaks BSP. So another point, Scala is not a good fit for scripts or small programs. How many people care about this? Because it won't be everybody. Do you want to just shout out what you would use for writing scripts instead of Scala? Bash, Perl,
Haskell.
PyScript,
Haskell.
Haskell. Yeah. Well, there is a very strong argument to be made that Haskell would be a better scripting language than Scala or Java because of the startup cost. We're not running native code. We're starting a JVM with quite large overheads, and that is expensive in time. And for command line tools, this is not acceptable. Now, there's another technology called Graal, which is a VM. It's also allows you to construct native code from bytecode. And that can be used to convert your a Java application, or indeed a Scala application, into a natively runnable application. And believe it or not, Fury supports Graal out of the box if you've got Graal installed. So you can write some code in Scala, compile it with Fury, and then you can install it as a command on your system. And maybe later we can even have tab completions. Tab completions which run the binary, give you the results back, like you saw with Fury. Now let me do a little demo of this. So we've got our project here. There's actually just one thing we need to do. I need to run Fury build install, and I need to pick a name for the executable. What shall I call it? FS Functional Scala 2019, like that. So it's building a Graal native image. Now Fury is fast, but Graal is not. So Graal is going to tick away for a few seconds, doing all the analysis that's required to work out how to create a binary that basically runs Hello World. 14 seconds, if you can see the time there. And if I then run that, look how instantaneous that is. We could have Ruby gems for Scala with this. We could be using Scala as a scripting language. We could see the development of libraries that make that much nicer, and it could be very easy to use those with Fury. So I think this particular criticism, that Scala's not a good fit for scripts or small programs, could potentially go away. So implicits are too complex. I started the talk by mentioning Scala 3. Scala 3 rewrites implicits. They're now called givens. And the code for givens looks a little bit like this week. And when I came to write this example on a slide, I couldn't get the syntax right for the most current release of Dotty because it had changed since I last looked at it. I'm not going to explain this, but this is intended to simplify the perception of implicits. They will be given a new name, which is given, and the hope is that it's a rebranding, but also a simplification. Publishing libraries is too difficult. Jon mentioned that I've probably written hundreds of libraries. I probably have, but I've published only a small fraction of them. Not very many of them are on Maven Central, because I just find it so hard. Probably harder than most people, and I'm very lazy at learning things like processes for publishing. But from
simpler or between.
Well, I haven't checked recently, but it's still too hard. I still think it's too hard. There's too many steps involved. If you've never published before, I believe you still need to open a ticket on Jira with Solacite. This hasn't changed, and then it might take a day or a week for that to be resolved. Yeah, but by that time, I'm 2 libraries down the road, and I've forgotten about the one I was working on before. The setup is too long. The process fails every so often, and it can potentially be slow, depending on what day it is. Sometimes it takes minutes, and it has been faster recently. It's not like I've never published, but it's been faster in recent years. Sometimes minutes, but still occasionally up to a day. So what I want to do is create a new way of publishing, taking advantage of IPFS as a peer-to-peer distributed network for Fury builds. And Fury builds, if you've seen or read anything else about Fury, it is source-based. So we're not distributing binaries, we're distributing sources. And that repository is a service that Fury will connect to. And you're probably all thinking, well, I'm just creating a new Maven that's going to be bad in other ways, and it might go down, and everything will stop working. I won't be able to build my code. These are exactly my concerns, so I'm going to try and address these as well. But I've set up furori.dev as an online repository of Fury days. It is not part of Fury, but it is a service that Fury will use. You'll be able to write your own version of Fury to the Furori to the API if you don't trust furori.dev, but I will make Furori available for anybody to publish their builds if they want to. And I will show you how that works. You'll be allowed to publish if you authenticate using OAuth on GitHub. So no Jira tickets, you just log in. And if you're a member of organization, then you can publish a layer called organization/project. So I can publish propensive/anything. And this is the check that is done. And we can publish with a single command. What that publishing process will do is it will share your layer. The layer is the definition of the build on IPFS. It'll store its hash in a catalog so it's accessible. Now, I think I'll do the demo now. So we've got this little program we ran here, we created. Let's say I want to share that with other people. Now, if I rewind a little bit to the very beginning where I tried to clone a layer, and I press tab there, I got a list of, well, you can count them, there's nine things currently on Furori. We want to add something else so somebody else can use our layer. So the first thing I want to do is authenticate myself with GitHub. Now, I'm going to type that, and in the background, you can't quite see it, but it's opened a web browser, and it's asking me to log in. So I'm going to log in as propensive, and you're going to see the length of my password. And then I'm going to go to my phone and find the authenticator. Everything's two-factor. I'm not going to show you the code just in case you're doing exactly what I'm doing. but trust me, I am typing it in now. You're lucky I typed it wrong. And it's also about to expire. I'm too slow anyway. So that's authenticated, and I just closed it. And it actually said up there, as soon as I did it, that you are now authenticated. And to publish my layer, I just need to give it a name. Let's call it Propensive/Functional Scala 2019. Count the seconds, and it's published. That's available for you to use. It's available at this hash if you want to access it directly, and it's also available at this human readable version. If you're referring to it from within the Fury commands, so if I want to run the clone command, you'll see now there's a 10th option there, FS 2019. That would be what you would see on your machine if you tried this now. So that, I think, is an easier process for publishing. However easy SPT has made it, by taking the sonotype step out of the process, I think it becomes easier. But you're relying, or this appears to be relying, on a single centralized server run by me. And where will I be in 10 years' time when you still need to run your legacy code? Nobody knows. So I want this to be resilient. I want there to be backups. I want this to be open for other people to produce their alternatives so that you're not relying on anything that I provide. I don't want a single point of failure. So you'll be able to configure Fury with a server. By default, you get furori.dev. If you install it on your local network, you can point it to a server that's running locally so that you can publish within your workgroup rather than globally to the whole world. TXT records, DNS TXT records, are going to be used to provide a backup. So if the furori.dev server goes down, it will always have kept a TXT record up to date, maybe sort of 5 minutes behind the most recent publishes, but as up to date as possible, a TXT record which points to an IPFS file, a hash pointing to a file, which contains the most recent copy of the catalogue of layers available. So this is the backup option. If furori.dev disappears, you will still be able to access the list of layers. You'll be able to depend on them. It will go via things that don't rely on any single centralized server. So that was an important factor in the design. I did the demo. And this is the final one. I don't know what we do about this. Does anyone have any suggestions?
Extension functions.
So what, put extension functions in Scala and then the Kotlin users will...
No, but semantics. That's a very nice option. And then coroutines might be nice.
Okay, so just provide all the features that Kotlin provides. I think if the other 9... Yeah, I'm open to suggestions.
Actually, I have a couple of suggestions slash questions. So I tried Fury and actually I liked it, but there was no declarative configuration.
No, there isn't.
Do you plan?
No.
Why?
Sorry?
Why don't?
Well, this is a longer discussion.
Okay.
I'm only after suggestions for how we deal with Kotlin stealing all the beginners at this stage.
Another thing, IntelliJ support.
So okay.
Do you have for later or not?
IntelliJ. So through BSP, yes, IntelliJ. Through the work that JetBrains actually did, yeah.
And just one more question. Sorry. We had to create a generator of SBTBLs.
It wasn't a general questions invitation, but if there's time at the end.
Sorry. Actually, it is a suggestion. So what's okay?
Sorry.
Concerning the
Igor.
Kotlin, sorry.
Oh yeah.
Concerning the Kotlin,
Yes.
I think that the fact that you can program Android apps in Kotlin and Google supports it, that makes Kotlin very strong.
Right. Yeah. Igor.
Is this really a problem, though?
Well, that's maybe it is, maybe it isn't. I actually think that if we can make progress on the other 9 issues that I went through, then this will maybe make Scala cool again. This will. Sorry, yeah. Yeah, I sound like I'm sort of wearing a red hat. Make Scala cool again. I'm certainly. Yeah, you're right. It was always cool, but make it even cooler. Was it keep Scala cool? So, if we can fix the other 9 issues, I think we can make progress on this. I think Scala will start to be seen once again as a cool language, especially with the opportunity to basically have a clean slate to work with. We get to start afresh with Scala 3. We can say to people, if you had issues with Scala 2, try Scala 3, try the new build tooling, try the new IDE, and you might find that you actually like it a lot more. And the appeal of Kotlin is not so great. Kotlin might be sort of seen as a gateway drug to Scala. That remains to be seen. So just to summarize, I think there is right now a lot of hope and expectation around what is coming in the next few years. Scala 3 is the main driver behind that. But it's an opportunity to start again, it's an opportunity to get a fresh new set of tools and to go into the next generation of coding with Scala. I'm extremely excited about it. I've never been so excited about Scala, or haven't been so excited for 10 years or so. This is the first time that so many things are coming together around the same time that we're actually going to get a brand new, exciting, new developer experience with Scala 3, with Fury, with Metals. And you should be excited as well. So thank you.